Hey everybody, we are continuing our pre-calculus 7.7 product to sum and sum to product formulas. So in the previous video, you had three product formulas where you multiplied a sine times a sine times a cosine, and a cosine times a cosine. Now we're doing a sine minus a sine. You have 4 theta minus 2 theta. So that's not 40 minus 20. Okay, so I wrote out the steps. So if we have sine of A minus sine B, that formula is 2 sine A minus B over 2 times cosine A plus B over 2. By the way, just as a side note, the reason for the little a is because in Greek it's like alpha, and the reason for the capital B is because it's the beta. You know, it's like a capital B with a little stem at the end. So what I'm doing is I'm taking my 4, because that's bigger than 2, and the formula has 4 minus 2, and I factored out the theta, like your greatest common factor, over 2, times the cosine of the average, like adding 4 plus 2 over 2. So here's the work, and we do 2 over 2, which just cancels, and we do 6 over 2, which cancels to 3. So then your answer is 2 sine theta cosine 3 theta. On the next one, our first step is to recognize that it's a sum of 2 cosines, and your first step is actually to change the order. We want alpha bigger than beta, like we want A bigger than B. And so the first step for you would be the same thing. And then we use the 2 cosine A plus B over 2 times cosine A minus B over 2. Because if you didn't reverse the order, then it'd be like a negative. And in this problem, we don't want to do that. Since it's the sum, we can reverse it with no issue. And so we want to do that. It's easier to work with. So we substitute our numbers. We have 4 and 2. So 4 plus 2 is 6, over 2 is 3, and 4 minus 2 is 2, divided by 2 cancels. So you get 2 cosine 3 theta cosine theta. Now on the next one, it's so complicated that I worked out my numerator part here, and then I put my denominator part. So on this one we have sine theta plus sine 3 theta in your numerator. So your first step is just to reverse it. So you have 3 theta and theta. So then here's your sine formula. You remember, if it's a sum, then it changes to a product. And I wrote down the formula I used. And if it's 3 theta plus theta, you can think of that as 3 plus 1. So we have 3 plus 1 was 4, divided by 2 is 2, and 3 minus 1 is 2, divided by 2 is 1. So in your numerator, you get 2 sine theta, 2 theta times cosine theta. Then for your denominator, you don't do anything with it. So you just leave it alone. Okay, on your next one, you have sine of 5 theta plus sine theta over cosine 5 theta plus cosine theta. Remember, you can't just cancel these, because if you have a compound denominator, then you can't do that. Compound just means if you have a plus or minus in the denominator or downstairs, then you can't just split it. So here's my numerator work. I have a sine, and so 5 plus 1 over 2 is 6 over 2 is 3. So there we go. And then 5 minus 1 is 4 over 2 is 2. So this is my numerator. Then I work with my denominator, which is a sum of cosines. And so here's my formula. And so again, plug in 5 plus 1 over 2 and 5 minus 1 over 2. So you get 6 theta over 2, which is 3 theta, and 4 theta over 2, which is 2 theta. Then what I did is I combined them. So my numerator is on top and my denominator is on bottom. Then we're going to cancel out the 2 theta because they're canceling to 1, and also cancel the 2's. So that means you're left with sine of 3 theta over cosine of 3 theta. So then what you do is you look at your quotient identity, and if it's sine over cosine, then it's tangent. And so there's your tan 3 theta. So there's all your work for it. But it is multiple choice. Okay, on the next one, we have a cosine of theta plus cosine 3 theta over sine theta plus sine 3 theta. So again, we want to switch the order for A greater than B. So for your numerator with your plus, here's your formula. Remember, these formulas, whenever you have a sum or difference, involve times. That little star is a times. So we have 2 cosine of the average times cosine of the difference over 2. So we put our 3 plus 1 over 2, which is 4 halves, or 2, and 3 minus 1 over 2, or 2 halves over 2. Or just, I'm sorry, 2 over 2, which cancels to 1. So then for our numerator, we have 2 cosine 2 theta times cosine theta. So that's your numerator. And for your denominator, we do the same thing with reversing the order. And then this is our formula. The difference is, like, if you are adding 2 sines, then it's going to be 2 sine cosine. Whereas if it's 2 cosines you're adding, it's 2 cosine cosine. So that's what's different about it. You're still doing your 3 plus 1 over 2, which simplifies to 2, and your 3 minus 1 over 2, which simplifies to 1. So your denominator is 2 sine 2 theta times cosine theta. So now I combined them. Your numerator is there, and your denominator is here. The next step is to cancel your 2's and to cancel your cosines. So you have cosine 2 theta over sine 2 theta. Now, since it's exactly the same angle, then you just look over at your quotient identity and see if it's cosine over sine, then it's cotangent. So then our answer is cotan 2 theta, which is what we wanted over here. So what you're looking for is what step matches what I did, or what we did. Okay, on the next one, this one we have sine 4x. So this time they're using x instead of theta. Sine 4x plus sine 2x over cosine 4x plus cosine 2x. And we need to prove how that equals tangent of 3x. So our first step is think of A as the 4x and the B as the 2x. So this time, instead of working the numerator and denominator separate, since we're getting the hang of it, I just went ahead and put the numerator information on top and the denominator information on bottom. So those are the formulas we're going to use. And then we're going to do 4x plus 2x over 2, followed by 4x minus 2x over 2. And in our denominator, we're going to have cosine with 4x plus 2x over 2 and cosine 4x minus 2x over 2. So what we notice about that is we can cancel the things that look exactly the same. I mean, you can even say if there's a giraffe on top and a giraffe on bottom, your giraffes cancel. So even if it's like cosine 4x minus 2x over 2, if it's that on top and bottom, it's just 1. So that cancels. And then 2 over 2 is 1. And so then we're at this step where you have sine and cosine of the same angle. So at that point, I started simplifying, and 4x plus 2x is 6x, divided by 2 is 3x. And you have that for both the numerator and denominator. So if you have sine over cosine, then you look over at your quotient identity and see that's tangent. So then sine 3x over cosine 3x is really tangent of 3x. And so that's how that works out. And so then you just find which one matched what we did. Now, number 13 was a little bit more complicated. The reason was because when I started working it, I see we have a plus in the numerator, and so I switched the order. But then what I noticed was the denominator has a minus, and if there's a minus in the denominator, we can't switch the order. And as you see in the multiple choice, they just kept it with the smaller angle first. The 2 theta is smaller than the 4 theta. Just like 20 is smaller than 40. But it's really theta, like whatever theta is, if it's pi 6 or whatever. Okay, so if we don't switch the order, then it works out like this. We have sine 2 theta plus sine 4 theta, so that turns into 2 sine 2 plus 4 over 2 times theta, and then times cosine of 2 minus 4 over 2. So that's your numerator. In your denominator, you'd have 2 minus 4 over 2 and 2 plus 4 over 2. Again, what's weird is the first part has sine and the back part has cosine. That's because we're doing the sine minus sine. So that's why that's the formula. So your next step, just to simplify it, is to cancel your 2's. And then we do our 2 plus 4 is 6, divided by 2 is 3. And 2 minus 4 is negative 2, divided by 2, is negative 1. What you notice is your sine of the same, if you have sine and cosine of the same angle, that's going to simplify to tangent because sine is in the numerator and cosine's in your denominator. Now for this other part, I just took steps. You have cosine of a negative angle over sine of a negative angle. Now again, before this problem, we just put the larger angle as bigger, but we couldn't do that with this one. So what you have to do is use your odd and even identity. So they're over here, and if you have sine of negative x, that's negative x, or negative sine x, because what that means is if you're going backwards, then your sine would be a different, it'd be below, which is a negative value. But for cosine, it'd be a positive value still. On tangent, it would have to be negative. because you're in the quadrant with plus minus. And tangent is y over x, which is negative over positive. And so that's why tangent is negative and sine is negative. Those are the ones we need. And then cosine remains positive. Okay, so what we're doing is we're interpreting cosine over sine as cotangent using your quotient identity. And then, so that's right here. And then you're using your reciprocal identity that cotan is the same as 1 over tan. So if it's 1 over tan, I can just put it in my denominator. And for your last step, you use your odd and even identity, that if you have a tan of a negative angle, then it's negative tan theta. And so that's why the minus sign goes out right there. So that's problem 13. Okay, on problem 14, this time they're using y and x, and we're subtracting, so you don't, you wouldn't switch the order anyway because there's no coefficient in front. And so here's your numerator formula and your denominator formula. So then you're going to cancel your 2's, and if you have sine and cosine of the same angle, that's tangent, and that happened to both. And so that one was kind of easy. Now on your next one, okay, so that was the end of all your establish the identity problems. On this one, they actually want you to get all of your solutions between 0 and 2 pi, which is basically from 0 to 6.28. So I started working it, and I got 2 of the answers, and then I started working over here, and I was like, y'all are not going to want to do that. So what I did is I just graphed the left side as F1 and the right side as F2. So let's do that. You do have to be in radian mode for this when you're graphing because it's trig. And we have to press the trig button and go sine 4x. So we don't really put theta, we put x. And then minus sine 2x. So there's your graph. It's really wavy and unique. It does repeat over and over. That means it's periodic. So since we want from 0 to 2 pi, we go menu 4, 1 and go 0 to 2 pi. Okay, so that's like that. And the first one you can see is at 0, and all of your answer choices start with 0. So then what you do is you go menu, analyze, intersect. Whoops, did I put in F2 yet? No. My F2 is going to be 0. I don't know if yours is going to be 1 or -1 or what it's going to be. Okay, so there's my second one. So that's the red line. And I need to see all the places the blue line crosses the red line. So we go menu, 6 for analyze, 4 for intersect, and we just do these one by one. We go like this and trap it, and then I wrote down my answer, 0.532, or I mean 52359, which I ended up rounding. So there's the first one, and then you go menu, analyze, intersect, and then you go for this one. Now, in your case, you're probably going to have to do what I did. You're going to have to move it, so you just like use it like a mouse, and then you have the hand, then you push down hard, hold it, and you notice it clenched the number, and then you're going to have to move it, and then you drop it. like that. So there's your 1.57, and you do that the same thing over and over again. So this part you really want to write down, so I'll keep it right here. 0 was an answer, and then these are all your decimals. So then what I did is I used the fact that it's a multiple choice question, and I compared all my decimals. So then what I did is I said, okay, there's pi over 4. Well, if I do pi over 4 on the calculator, I get 0.78, and that's nothing I want. So anything with pi over 4 is not the right answer. And then I see my next smallest is 6. Like pi 6 is smaller. So if I do pi over 6 as a decimal, then I get 0.52, which is what we wanted. And so this one's wrong because of pi thirds, and this one because it's going least to greatest. So now you're down to 2 choices, and I just kept on going, and here's your equivalence. So the 0.52 is pi sixth, the 1.57 is pi halves, the 2.6 is the 5 pi sixth, the 3.14 is pi, the 3.66 is the 7 pi over 6, the 4.71 is the 3 pi over 2, and the 5.75 is the 11 pi over 6. So that's a lot of answers because it was so wavy and kept on crossing the x-axis. Okay, so your next problem is a word problem. It's the last one. It says, on a touch-tone phone, each button produces a unique sound. The sound produced is the sum of 2 tones given by sine of 2 pi times a lower times t and sine 2 pi times the higher times the t. Again, where the L is the low and the H is the high frequency. The frequency is the cycles per second, and they show you how many cycles there are. Now, in the problem we're doing, it's about 9, which is 852. And so they're showing you the formula that has 852 substituted for your low, and then they used 1477 for the high, because that's the hashtag or pound sign. Okay, so for 9, we have this formula, and I labeled it low and high. And then I did the sine part, and I did 2 times 852 plus 2 times 1477 over 2, and I got 2329, which is what they use in the formula. And then I did the cosine part, which is, well, what I first did on the cosine part is I didn't change the order, and I got a negative answer, but I needed to reverse it. And so then I did 2 times 1477 minus 2 times 852 all over 2. And there you get your 625. And so that's what we wanted. Then the next step is you want to graph it in radian mode, and you can graph that. Just make sure instead of t you put x. Use x instead of t. And then it wants your whole number maximum, which in our case is going to be 2, because that's as high as it gets. All right, so that's the end of that video. Hope that helps.